So what we're doing here is ABC is a triangle. D is a point on BC. We can see that. Now, the first thing it wants us to find out is DC. DC is this target here. Now, the most information is on the right-hand side triangle. So the triangle we're going to use is this one here. Oh, sorry, 1 second. We're going to use this triangle here, A to D to C. Everybody cool with that? Now, first piece of information I can get quite cheaply is if I add 62 and 70 together, I get 132. Take 180, take away 132? 48. You now know this is 48 degrees. Now, we can use the sine rule. I can say that DC divided by sine what? What looks at the DC? The sine? 62, yeah? And then what looks at the 8? The sine 48. Sine 62 is division on the right, on the left, which will make a multiplication on the right. This means when we move the sine 62 from the left to the right, it goes up beside the 8 in multiplication rather than beside the 48 in division. You put all that into your calculator and what you get? Anybody get the answer? 9.5? Okay. Since there's a bit of uncertainty, we're going to obviously have to do it out, aren't we? Okay. Okay, and we get 9.5 as you said. Okay, no bother. Now, area triangle ABC, okay? So how do you do ABC then? The area of the triangle ABC. Now, it's not we're going to have to use a half AB sine C. Would you agree with that? That's what we've been using in this chapter. Now, it has to be the full triangle, so we're going to need 2 full lengths. What 2 full lengths do we have? Yeah, we know B to C, don't we? What's B to C? It's your 5 plus your 9.5, which gives us... All right, we know the 8 as well, don't we? So it's the 8, the 14.5, and then what's in here? 70. So what can I write down? Half AB sine C for the area. It's an area question. So it's a half 8 times 14.5 sine what? 70, was it? You look back at the top, that's a 70 there. It was to rub that out, 70. Anybody get this answer? 55, is it? ABC is the full triangle, yeah? I'll show you now. Sam, would you agree I have this length here? Would you also agree that I have this length here? All the way across, yeah? To get the area of a triangle, I only need to know 2 full lengths and the angle that's in between them. Do I know the angle that's in between them? 70. So that will get me the full triangle. Is that okay? So half AB sine C. And Paul said 55, was it? Yeah. Any questions? No. All right. Now, Q is a ship and it starts off at port P. Everybody see port P? Now, Q is represented by the black dot. It goes 45 degrees west of north or north of west, whichever way you want to say it. A second ship R, where is ship R? Is 43 kilometers from P. So R is here, we call R the red ship, and it's 53 kilometers away from P. In the direction from Q, so it's south 75 degrees east. So we know that's 75. Calculate QRP. Which one's QRP, lads? Which one's QR to P? We have to calculate that angle there, don't we? Everybody happy with that one? Now, how we're going to do it is a different matter. Okay. Okay. We need 1 full angle to make this work. Can anybody tell me, how do I know this is 45? No, but why is it 45? There's something that some of you would have got taught. If you see an N or Z with parallel lines, when you see an N or Z, the 2 angles are the same. And what I'm seeing here is I'm seeing like something that looks like an N or a Z. I'm seeing this green line here. See that one to there and back again. I can tell straight away that that's 45 degrees. Now when I add both of them together, what do I get? 120 for that angle there. Okay, now it still doesn't really help me. Actually, it will help me. I can use the sine rule. How do I use the sine rule to get an angle? 53 over sin 120. Yeah, I can work with that. What's next? X over sin 37. Yeah. Now, no. Sam, 37 is the length. So it's 37 over sin X. Angle question or length question? Angle. What way do angle questions end? Sin inverse, cos inverse, or tan inverse? In this case, which one do you think it's going to be? Sin inverse. Okay. Now, bottom right goes to top left. Division on the right is multiplication on the left. 53, which is multiplication on the left, will be division on the right. Sine 120, which is division on the left, will be multiplication on the right. And your 37 stays where it was. It was multiplication on the right, and it's still multiplication on the right. Throw all that into the calculator, and what you get? Paul, do you have this? Okay, so let's get into the calculator, guys, and verify my answer for me. 37 sin 120 divided by 53. 0.605. And then sine inverse that to get the angle I'm looking for. So press shift sin inverse 0.605. And what you get? 37 to nearest degree, or one decimal place? One decimal place, so 37.2. Because I wrote it in my calculator, it has to go on my sheet of paper to get marks. Please never forget that, okay? Everybody happy so far? Now, next thing is QR. We have to find out where QR is. Where's Q to R? We can target Q to R here. Like so. Now, because we know the angle of X, we now know all three angles, don't we? Okay, we should do anyway. We will in a second, Sam. Okay, that's is everybody having that other angle's 37.2? We just got it a second ago, didn't we? So get 180, take away 120 and 37.2, and what you get? Somebody in the calculator. 180 minus 120 minus 37.2. 27.8? Awesome. Okay, you have two choices. I can do the cosine rule, or I could do another sine rule. What would you like me to do? Cosine rule or another sine rule? Okay, yeah, you have an option, right? I'll explain your options. Your first option is, guys, sorry, get a line here. Your first option is to use these two blue lines here. You see the two blue lines? You know the 37 and you know the 53, don't you? That's an angle sandwich. Would you agree with that? And that means you could have used a squared equals b squared plus c squared minus 2bc cos a. That's all right. And what would you get there, guys? We call the yellow line a. Is that okay? So we call it a squared. Now what's b squared? Will somebody put this into the calculator for me? 53 squared minus 2 times 37 times 53. Cos what angle? What's the angle that's in between those two blue lines? 27.8. Okay. Put it all into your calculator and find the a squared value for me. What you get? 708.67. I'd expect this, I'm expecting this side to be the smallest in the triangle. Square root that, Peter. 26.62. Okay, that is a perfect answer for me because it had to be below 37, didn't it? Why did it have to be below 37? Yeah, 37 degrees faces 37 kilometers. This would imply 27.8 degrees faces something much smaller. Now, somebody else could have came along and said, look, I didn't do it that way. Could I do it using the sine rule? Would I still get 26.6 as my correct answer? Let's find out. Choose 53 over 120, no bother. What if this is side A, what angle do we have to use? 27.8. The 27 sine 27.8 is division on the right, which will make it what? What does it make it on the left? It makes it multiplication on the left. Well, lads, will you throw that into your calculator and tell me what you get? If you don't get 26.6, something's up. So 53 sine 27.8 divided by sine 120. $28.54. Did I? Oh, it's 22.8. Oh, so lads, that's 22.8. All right. Shh. Lads, can we stop here for a sec? Shh. All right, come in. Lads, just when we added the two of them up, it was actually 22.8. So we're just going to have a look at the cosine rule. John, will you tidy up the cosine rule for me using 22.8? Okay. Owen, will you do the sine rule using 22.8 this time? So not 22.8, not 27.8. Okay. And we'll see what happens. So John, what did you have to square root? 500 and point and square root that, and what you get? 23.7. Great. Now on what you get? So just do 53 sine 22.8 divided by sine 120. What you get? $23.71 and was sorry, about 23.7, aren't they? So that's good. So both answers match up. Okay. Okay. A surveyor wishes to measure the height of a church, measure the angle of elevation. She finds that the angle increases from 30 to 40 after walking 25 meters towards the church. What is the height of the church correct in nearest meter? All right, I'll just answer part 2 and 3 first if I can. You're going to use that opsometer, sorry, not the opsometer, the clinometer, right? So you're going to use the clinometer, okay? Now, if you don't remember what a clinometer is, it's basically a device that essentially has a weight at the end of like a protractor, okay? So you have your protractor here. It's actually oddly enough upside down, okay? And it has a weight hanging from the bottom, like so. When you tilt see the way it starts off at 90 degrees on the bottom? Everybody see that? See the way it starts off at 90 degrees? When you tilt it upwards to match your angle, so when you start facing upwards, you go up like this, and you can see roughly that went from 90 degrees to 120. This means that the angle you actually went up was 30. Does that make sense? Because gravity always acts straight down, so I was able to tell how far you tilted up your measuring device. Is that okay? Now, what we're going to do, so we just explained parts 2 and 3 already. Now, the big question is, how many right angles, sorry, not even right angle triangles. Let's fill out as much information as we can. I'm going to claim that's 90 degrees. How can I claim that's 90 degrees? Yeah, we're assuming it's vertical to the ground. What angle is this then? I say it's 50. Why is it 50? Yeah. I'm also going to claim this is 140. How do I claim that? Straight angle. I'm then going to claim this is 10 degrees. Why? 180 minus 170. Now, what does it want from me? It wants the height of the church. So the goal of the question is to find out what is the height of the church. Can anybody tell me what's the most important line in this question? There's one line that's the most important line. Now, it's not the height of the church, okay? Can anybody tell me what is the most important line in this question? Okay. I'll highlight it now. I think this one's the most important line in the question, and I'll tell you why. It's the line that links both triangles together. You can use the triangle with more information to get the blue line, and then that information is now in the right-hand triangle as well. Does that make sense? So when I find out the blue side using the left triangle, that information is now in the right triangle as well. Okay, let's work on the triangle on the left. So the triangle on the left is obviously the weirdly shaped one with the 140-degree angle in it. Okay, what do we know already? We know that's 30. What's opposite the 25? What angle is opposite the 25 meters? Huh? 10? Yep. Angle of 10 degrees is opposite the 25 degrees. So here's 25. There's your angle of 10. What about here? 30. Okay. And we want the blue side. Let's call it X. Yeah. Sine rule or cosine rule? Length or angle question? Length question. Okay. So it's going to be X over sine 30 equals what? Anybody? Sine 10. Yeah. Next step, Oscar. What about the sine 30? Multiplication. Perfect. Somebody put that into the calculator and give me my answer. 71 point. Yeah, 71.98. Just want it to the nearest. So just keep it that way to start. Now we have information for the right angle triangle now, don't we? Okay. What are your options when you're using a right angle triangle? You can use SOHCAHTOA. Are we going to use SOHCAHTOA? We can use Pythagoras as well. Are we going to use Pythagoras' theorem for this question to find out the height of the yellow line? And I would say we can't use Pythagoras' theorem. Why? Don't have two sides. Are we allowed to use the sine rule or the cosine rule? Yes, they work on any triangle regardless if it is right angled or not. Would you recommend using SOHCAHTOA? I would. Why am I allowed to use SOHCAHTOA? It's a right angle triangle. And is this an angle or a length question? So opposite is H, hypotenuse is 71.98. What function should I use? Why am I using sin? Okay, so sin 40 is what, guys? H over 0.98, then what? H equals cross multiply, division, times. Okay, and what should your answer be? Put it into calculator, find out. Off you go. 46.3. All right, great.